Hello everyone. It's JavaScript fwdays' 2023 conference, and the next talk is from Eric Meier. Eric is a serial entrepreneur and co-founder of startup. He maintains a Slate YGS library and active contributor to Slate. The fun fact that Eric, I've been obsessed with building collaborative apps and distributed systems for the entire career. So it's not a surprise today Eric going to talk about CRDT. As usual, during the talk, please post your comments or questions to the public GSFW Days channel like Discord. After the talk, we will have a live Q&A session, and then we will have a live chat in the Discord. So it's time for presentation. Please welcome Eric. Hello, Eric.
Hi, so nice to be here. Today I'm going to be talking about how to build better apps using CRDTs. And the first question you might have is like, why should you care? Aren't apps good enough right now? Well, if you think about the most delightful apps you've tried over the last couple of years, there are like a few apps in particular that come to mind for most people. And those are apps like Linear, Figma, and Notion. And they come to mind to most people for usually like a few of those like very particular reasons, which is they feel incredibly snappy. They offer live collaboration. So yeah, multiple coworkers can join a document or like a Figma canvas at once and collaborate at the same time. They're resilient. I've never lost any data on any of them. If the network connection drops, you most likely won't even notice it. They offer reliable and global under redo. So if you accidentally delete a task in Linear or delete something in Figma, you can be confident that you can just hit undo and that stuff is there again. But all of those changes have one thing in common. They're incredibly hard to actually implement because they all rely on config resolution and on very, very complex config resolution. So to implement that, it's actually not trivial. It's quite complex. You see one naive implementation here for how someone would implement something like Figma, which is you store just the state of a shape in JSON in your database, and you just override them, which would be a very naive approach. Because if you have now two clients that are modifying the same shape at the same time, or one client is offline and modifies the shape, and another one modifies the shape while he's online, and you merge those changes back together, you actually end up with, because they override it, you either end up with the green square or the orange circle, and you drop changes of one user, which isn't the desired state. Just what you ideally would want in this case is because one user changes the color of a shape to green, and the user B changes it to be a circle. You would expect it to be a green circle, but to get to this state, it's incredibly complex to actually implement. And there's a way more stuff. Now, if you add undo to that, and you dropped changes of this user, for example, then it gets very, very complex very, very quickly. And how can you actually implement that in a nice way without pulling your hair out, failing Google did to implement an algorithm that works? Google had 3 operational transform implementations. They were all proven incorrectly until they actually found one that worked. You can use CRDTs. So what are CRDTs? CRDTs are conflict-free replicated data types. You can kind of think like them, like JavaScript objects and numbers and arrays with a magical merge function, and they have change tracking built in. There are a lot of different CRDTs. All of them have very specific characteristics and are for very specific use cases. There are registers, which you kind of think can think of like a container that just holds a value, and for example, the last write win register always retains the state of the last added value by any user. There are counters for like voting and likes, for example. There are sets, maps, and like CRDTs for specific like text use cases and lists, and there are like many more. So what does a CRDT actually look like? What I'm like talking about here. Let's show a concrete example. A last write win map. Why a last write win map? Because if you would have used the last write win map in the previous example, you actually would have ended up with the correct state. So one thing we can just do to make this work is, instead of store the shape as a plain JSON object, we store it as a last write win map. And we just on the database, instead of just overwriting it, we just call state, like the current state in the database, and then like the magical merge function of the last write win map. How that works, I'll show you in the next slide, and the remote state. And you will end up with the actual desired state without even doing that much changes. Yeah, so you see the both changes again. Like user A changes the color to green, user B to a circle, and you end up with a green circle. And how does it work? It works by storing additional metadata. Sorry, it's like I messed up a bit. So instead of just storing the plain JSON object, you store different like additional metadata. So instead of just storing shape, you store the current value. But here's the like very clever part for last write win map. You also store a last updated at, which in this case is A1. And you might expect a last updated at to be just a plain timestamp, which might work. The issue is that CRDTs are built for distributed systems, and in distributed systems, you can't really trust time. What do I mean by that? Is that you can't trust your clients to have their clock exactly in sync. And if that would happen in this case, for example, and you just store a timestamp, then the time you set it to might be incorrect, and that will cause issues further down the road. And to get around that, CRDTs have use what I call Lamport timestamps, or at least most CRDTs do, which is, instead of thinking about time as like plain time, you reference the time based upon the last operation you've seen. So in this case, it's A1. So like time would be 1, because like 1, that's the like first operation that's been done to this object. Like the next operation, which would be set the color to orange, for example, during initialization, would be 2, because 1 was the last seen operation and now it's 2. And you also store the client ID. The client ID is uniquely generated. Usually it's like a UID or some count of connection counter if you have a central server, which you then use as well to do conflict resolution, because you could have 2 clients with the same timestamp in this case. But if you include the client ID, which is unique, then you can always check if like one change happened before one another. And this actually makes the merge function quite simple in this case, because the merge function literally is iterate over each entry in those 2 lists from the example before. We have now like the 2 changes from the client. So like one client set the color to green, which updated set the last updated at timestamp to 2, because it was the first operation that was done to that from that client. It sets the other client sets the shape to be a circle, which changes the timestamp again to like 2, and the client ID is B in this case. Then we like iterate over the entries. We check, is B2 greater than S1? And in this case it is, because 2 is greater than 1. And for the color we check, is A2 bigger than S1, which it is in this case. So we set the value here as well. And then you end up with the state you actually want, which is a green circle, and the updated values are correct. Again, that's like visualized in the example from before with the correct states. Both start with like the initial state of the shape. They updated, the timestamps get updated. The server calls current state and merge remote state for each of those changes. The order doesn't matter because you will either way end up with this state because if you apply this first, you will just end up with this state, and then you apply this one, and like it will end up with like this exact state. But because like this value is bigger than this one, it will have the value of circle because of the merge function. Yeah, actually, it's like people are usually afraid of CRDTs because it like sounds complex. But to implement this like very simple last value unwrap in JavaScript, it's like only like very few lines of code, as you can see here. But the like really cool thing about this abstraction that we've created here is that you can very easily build on top of it and optimize on top of it. So for example, if you right now we'd send the entire state of the CRDT on every change, which is fine because that's like a superpower of CRDTs. You don't actually have to only submit every operation once. You can just like throw them over the wall. Because if you think about the merge function, if you like resubmit the state or this change, nothing will happen because B2 is equal to B2 in this case. And you can just like overwrite the value. In fact, like, you should only overwrite it if it's bigger. So like this won't change anything, like resubmitting it. So you can literally just throw those changes over the wall, and it like doesn't matter, which is really nice for like reconnection handling as well. Because in this case, like what you can do is just have the client send like here's my current state, or like you just send literally the timestamps and like ask client be like, hey, what did change since those timestamps on your site? And in this case, the state that we sent over is the state from the example, which is A1 and S2. So color, timestamp A2, shape, timestamp S1. The other client checks, yeah, like color, like you have a newer thing, so I won't send anything over. But for shape, I actually have a change that happened afterwards. And so I'm gonna send that over, and then you can build like really, really efficient protocols around that are like highly resilient. And the like really nice thing about that as well is that you actually don't need a central server for this, because we can just like throw changes and like randomly merge them together, and you don't have like a random authority that owns the changes. There's no reason to have to send everything to a central place. And you can just have like really small edge servers all around the world and have them like connect to local clients and then like broadcast those changes together then to like a central server later on where you can like update your database. But that way you can have like really highly performant collaboration without any of those like where do I spawn the central server for those two users kind of issues. But yeah, this was only like a very simple example of a CRDT. Text CRDTs tend to get a bit more complex, but actually like once you dive into them, most CRDTs have a very simple core and are actually like way easier to understand than you think. And all CRDTs have like those properties I just told you about. So like the order in which you apply changes doesn't matter. So you don't have to have like a central server that keeps track about like client A applied changes before client B, and they're idempotent. Idempotent. What do I mean by that? Applying the same changes twice doesn't really matter. which is what gives you those superpowers of not having to keep track of changes in like a central server. And yeah, the good thing about those two properties is they're shared by all CRDTs. So you can treat most CRDTs as sort of a black box. But you should look into what trade-offs specific CRDTs do and what merging characteristics they have. And for the few ones I showed before, I added what trade-offs they have here. So for example, for counters, you could choose a G counter or a PN counter. The G counter is more efficient, but the PN counter, for example, can also decrement. That's something that's not implemented in the G counter. It's the same one for the sets. Actually, like I simulated a bit similar under the hood. So that's why there's like a G set, which you can only add items to. And there's a 2P set, which also has a remove operation. But to make that remove operation, like the G set is implemented very trivially. It's literally just store everything you ever added to it, give it like a unique ID using a timestamp, and then just check with each client if each client has like all changes. But yeah, in this case, like you can't really delete anything because there's like no way to indicate, hey, this item has been deleted. To add delete, we add just another G set, which holds all the like set of deleted items, which is additional metadata. But this way, yeah, you can have a delete operation. Then a few different maps, like the last write win map, which we again can't really have a remove. If you think about it, you can set it to undefined, but you can't remove a key. You need to have additional metadata for that, which then would be the OR map again. And there are like a ton of different text and list CRDTs. You really have to look out for those for the memory footprint of the CRDTs, because like text CRDTs tend to store a lot of additional metadata, and especially with TreeDoc, you might run into like huge document sizes after like a lot of editing. But they're like highly optimized like RGA implementations that like tend not to have this problem. But yeah. So how can I use CRDTs? They sound awesome. Well, for the JavaScript, there is a like library out there that's called YJS, which is a like really, really highly efficiently implemented list CRDT. And around this like list CRDT core, there are like exposed a list of shared types, which are kind of like JavaScript types, as I mentioned before. There's a map type for storing like object-like data. There's a list type. There's a text type for storing like rich text. And there's like a few other utility types like XML elements and stuff like that. It has a thriving ecosystem. So there's a ton of tooling around YJS and how to build great apps with them. There's a built-in undo redo, and again, it's insanely fast and memory efficient. I can't emphasize this enough, because usually people are afraid when using CRDTs, like especially like text CRDTs, because they think, oh no, there's so much additional metadata. YJS does so many clever tricks under the hood to actually make it usable, like completely usable. It has like 2 or 3x the memory footprint of a like plain string if you just do inserts. So it's like really, really efficient. But yeah, how do I use it and how easy is it to use? Well, I'm going to show you because we're going to migrate to the app. The packages we're using is YJS itself, of course, and we're going to use Hocus Pocus. Hocus Pocus is just like way to broadcast changes between clients, because YJS in itself is just concerned with the conflict resolution. Hocus Pocus is a wrapper around like the YJS like sync protocol. Let's head over to VS Code and do it. So what you can see here is just, let me show you, yeah, dev. Oh, 1 second. That's, so what you can see here, a very simple to-do app where you can just add items. You can delete them, of course, you can check them off. And you can, of course, like it's not collaborative right now. So yeah, we have a different user here. He has items. Not collaborative right now. It doesn't persist changes. Yeah, it's just a very standard to-do app. Now let's make it collaborative. So let's run focus to broadcast the changes. And let's get started. So the first thing we need to do is to connect to the Hocus Pocus server to get a YJS document. A YJS document is the root that like holds all the changes, all the YJS changes. So let's do that. To the server I'm running here, which is just bootstrap it using the Hocus Pocus CLI. It's running on port 8080. The document name, which you can think of like the database key, is just to do. And now we have a like provider, which is again the wrapper around the document that handles like syncing the actual changes. And we need to get a shared type, which is the actual CRDT that holds the changes. So that would be use equals use. Provider. Oh, 1 second. Yeah, stupid. It should be returned like this. Because we have a to-do list, we just want to get a shared array type, which we will call to-dos. So it would be document, and under there there's an array that's called to-do. And the YJS in itself isn't immutable, and it doesn't have a React integration. So we actually have to do a small little trick, which I'm going to show you. I use a reducer to manually trigger re-renders on every change. So we don't have to convert the list and state and store it in like a React state like we do here. We can just use a use effect, and then we can say every time the list changes, so list.observe deep, we call re-render and like re-render the component. And that way we can just use the list, like the mutable list state in React. So we add the listener. So if something changes, we render. And then we get rid of the to-do state. Keep it in here just to show how it's working. Then we can use list to JSON in this case. We're going to optimize that. .map item e, and that should now render the state of the list. So we are almost there to have something that is collaborative, almost, because we actually need to change the state. And in this case, we're just gonna change the add to do, and instead of just updating the state right now, we are going to we're going to add it to the shared list. And to do that, we have to create a new import. We're going to have to import IDS itself. And because we don't want to share just store JavaScript objects in the list, we want to share types that can be modified by multiple users at once. We are going to create a new i.map, which is a different share type, which is used for storing object state. And we are going to push that. And we are, of course, gonna set the same properties. Which in this case, I just has very suboptimal typings. So in this case, we can only type the values of the thing. We can't do key values. So we actually create a new map, and we just say this map can have values of type number, string, or boolean. And for the list, we can actually specify the type of the values in here for TypeScript, which again is a map of a value of a number, a string, or a boolean. And you have to trace. And why just like a optimization thing. So you can push multiple items at once, which under the hood is more efficient to do. So that's this. And if we now add it to do, you will see. Add to do text. Oh, that's zero. You can now see that. Oh, it doesn't work. Let's do. So let's go real quick. List. Okay. And that's probably an error. The console, yeah. Okay. Let's do it the simple way, and let's do. The reducer logic. So yeah, if we read on now, we can add items, and those items show up collaborative. Let me clear the list again, so it's a bit more clear. And actually, because we have CRDTs and we saw the client state, those changes will be saved locally. So we have to clear both tabs and open them again. Server again, so the changes won't get resynced to the server, which is why they're so resilient. But yeah, no, if we add changes, you can see they are broadcasted to the remote client, which is like really, really nice. And amazing. And yeah, it won't get updated because we didn't put it from there. That's the like general gist of it. You just get a provider, you get a shared type, which in this case is a like Y array, which stores data2. You can like modify that in JavaScript, just using like would use like a JavaScript map, for example, for the map, or like a list in JavaScript with like a different syntax, because in this case you have to pass an array for optimizations. You have like some function that you use to like trigger a re-render in this case, so you don't have to like store the entire state in like a React state as well. So we can technically get rid of that. It's just here to make the other functions of the example work right now. And yeah, that's how easy it is to make a React app collaborative using fwdays'. And the cool thing about having the like re-rendering decoupled from the actual document state, so because we just request a re-render, you can first of all like you can use the new React Transition API to like deprioritize those re-renders, and which is like really, really nice, because you can have fwdays' actually to have like 100 people on the same document, again, because it's so efficient. But the bottleneck in that case isn't really fwdays', it's just the like it's React and the like re-rendering, because that will happen so often if you have like 100 users typing in the same document at the same time. But if you then combine that with this approach of like manually requesting re-renders and using the transition API, you can have like highly performant collaborative web apps that can handle hundreds of users. Okay, that's it. Lessons learned from building apps with CRDTs. Everything is a trade-off. One thing I didn't touch in this presentation is that they are wide, like CRDTs are awesome. There's like one big pain point with them, which is migrations and schema changes, because that's something you have to really, really think about. Because if you just like change data and overwrite data, you will lose the additional metadata or change the additional metadata that's associated with those CRDTs, which then again influences how remote changes are merged, and you can end up with some really painful migration code in the end to handle all of that. You should definitely spend some time understanding the like inner workings, or at least the algorithms behind the CRDTs you're using and the trade-offs. I see a lot of people just picking up fwdays' and the text type and start building editors around them, but they like have encountered like some edge case that is just because like how the config resolution works, which is something you have to look into with like all tools to do config resolution. But yeah, you should like spend a bit of time learning about that, how that works, and why changes are merged in a specific way. And it's actually like really beautiful once you know how like the inner workings actually work. And another thing is that enforcing permissions is a lot harder, because you usually can have like multiple like changes of multiple users on a single client. If you do stuff like broadcasting changes over RTC, or having like an edge server that like batches them together and then sends them to a central server, you have to dig into like the deeper levels of the protocol for fwdays', for example, to figure out like what actually changed. And you have to be sure to ensure that on the edge, in this case, so before it even gets stored on the like edge server, if you have like a global system, you have to be sure that that change is actually allowed to happen. And it's a lot harder than in traditional apps, but it's like totally doable. You just have to look into it. Also, maintaining WebSockets at scale is still a huge pain. Yeah, having to set up all that infrastructure, having to find this, because you can't just usually use like normal like versal edge functions, for example, because like no real edge servers right now has support for WebSockets. It's still a massive pain, but good news. Cloudflare brought out their like workers project, I think over like a year ago now, and it's like really really nice for use cases like this because it's like long running edge servers that are quite cheap and we can accept the WebSockets connections in. And they also have another product which is called durable objects, which you can use to have like a single like globally unique JavaScript object. You can kind of think about it that way, that is like smartly replicated, so it's like in the center of like all your users. So if you use that alongside with Cloudflare Workers, then you can build something that's like running on the edge, that's like highly performant, and that's like also very doable, like really really quickly. But yeah, there's still like some unsolved issues in the CRDT space because it's like very new. If you have like a JSON document, right now reparenting is not really solved in an efficient way. So there isn't like a CRDT that doesn't store a huge amount of additional metadata that allows you to say, hey, I want to move from key A.B to key C.E, like move that value. Without, again, like a lot of additional metadata, because the config resolution and that gets very, very quickly once you have like circular references. And moving and splitting text is also unsolved. It's not only unsolved in CRDTs, it's also unsolved in operational transform because you run into like a lot of edge cases like really, really quickly. But if you cleverly structure your data, you can get around both those issues. Yeah, you just have to understand a bit the inner workings again, like look into that, and then you can get around that. So that's it from me. Yeah.
Hello again, Eric. Thank you for the great presentation. We have a couple of questions from audience. The first one, it's a tricky one, is about the particular case, kind of how to remove or delete. I will then ask you to answer, to type the answer. I will send you a question because it's really hard to kind of read it right away. Okay, and the couple more questions. Maybe like what would you suggest? How to start with CRDT? So basically, should we someone does it make sense to someone to, I don't know, read the papers and kind of understand it really deep, or it's okay to just go ahead and use UJS library and build an application? How would you suggest to do that?
So, if you're like really interested in the topic and want to learn about the inner workings, there's actually like really great. First of all, I can really recommend the papers of Ink and Switch. It's called, like they're developing Automerge, which is another library. They have like great blog articles about like the inner workings of like a lot of their stuff. There also is great of like YouTube resources out there about CRDTs. There's a video called CRDTs, the hard parts, which is something I like really recommend. It's like a very interesting resource. But again, you don't have to 100% understand everything before using CRDTs. So if you just want to build a collaborative application, you probably like it's good enough in the beginning to just head over to YJS, like read a bit about the APIs of the different types, which are like very very similar to JavaScript. Then you just hocus pocus to like bootstrap a server. They also have like great docs around there how to make that like scalable, which you probably don't even need to have like multi instances in the beginning. Yeah, that's how I would recommend getting started.
Mm-hmm. Cool. Thank you. So it's something in the middle. So anyway, it's better to learn at least something about CRDT before using it.
Yeah.
Next question. What do you think? What apps or maybe even domains are good for CRDT, and what kind of collaboration maybe are not suitable for CRDT protocol, and maybe we should kind of think about operational transformation or whatever.
I'm a strong believer in that, like in the like operational transform versus CRDT case, like everything you would use operational transform for, you can do with CRDTs, and you probably should do with CRDTs because it's just easier to deal with. Right now, even the author of ShareDB, like wrote a part. ShareDB is like a big operational transformation like library or like layer server thing. It's kind of like Hocus Pocus. You can think of it. It does like transport, and it also does a bit more because it handles like under redo, but it's like agnostic of the like actual operational transform use. But even he said like, yeah, probably like you can do everything you can do with operational transform. You can do with CRDTs. So you should probably just use CRDTs because it's like it gives you more powers. Because operation transform, you have to have like a central server, and you have to like it's harder to properly implement. Operation transform seems easier on the surface, but actually like most types that are implemented, like most more complex types like JSON types are incorrect, and there are some scenarios where you can end up with like out of sync state because just it's so complex to think about. There are like exponentially more cases you have to handle. And to the first question as well, what apps should actually use config resolution stuff like this? Of course, probably like a blog website doesn't need it. Like it would be totally overkill to have like a CRDT for like a comment section, for example. You can get around that with like optimistic updates to have like a same-ish experience. As soon as you get into like more complex SaaS apps, like something like Linear or like Notion, of course, that's like a very good use case for that. But even for like the in-between things, like interactive elements on like a blog, for example, that aren't comments but like more interactive elements, like it might be good to at least keep CRDTs in mind so that you have this like tool to make something that's collaborative like very, very easily, and that you can have like without having to think about config resolution.
Okay, makes sense. So it sounds like we can do everything with CRDT, almost everything.
You could, but you should. I shouldn't.
Yeah, and you mentioned about the kind of huge apps or when apps become bigger. So what about the payload? Do you need? I maybe didn't get it from your slides. Do you need to send the whole state every time, or it's sort of difference between the states? How does it work? Could you briefly describe?
So, of course, like for the initial state you load, you have to send the entire state, but you only have to send the entire state of what you're currently displaying. So, for example, in Linear, you would have like a YJS document for each page, and then you just load the like for each canvas, and then like once you open the canvas, you load that entire state of the canvas. YJS also has like a very nice thing which is called subdocuments, where you can nest documents under each other and then like lazy load them. But yeah, you still have to load the entire CRDT state every time you open the document. For like doing changes, you can, there's like this synchronization protocol, which I like, why the one of YJS works similar. It's not quite like this, but it's very similar. And just say like, hey, this is my state, and you just send the like timestamps you have, sort of, and then like ask, hey, like what is missing from here, or like what do I need to send, like what don't you have, and then you just send the values that have changed, and that's all done. It's not like right here I'm displaying it as JSON. YJS is actually built around like a binary protocol that does like a lot of fancy stuff to make it faster. They have like run length encoding of the timestamps, for example, and then you end up with like actually like really, really tiny amounts of data you actually send over the wire. So like the optimizations make that not a problem.
Okay. Makes sense. Yeah, thank you. Sounds like not a big deal. Okay, thank you for your talk. We run out of time. Let's switch to Discord voice chat. So yeah, please everyone join us, and we will proceed discussion about CRDT.